All right, good morning. So today we are going to start a series of lessons. It's actually going to be 4 days about writing an equation to model the situation. So we're going to think back to some of the things we did like the first couple weeks of school when we were using algebraic expressions to represent verbal phrases. We're going to go back to, I believe it was the second day of that lesson when we talked about labeling variables, as in writing let statements. So I think we could skip past the do now here because there's going to be a lot kind of jammed into this lesson. So let's take a look at our question. It says a bus, as in one bus, brought 50 students to a football game, while 6 cars each brought the same amount of students. Okay, so we've got 6 cars, and they each brought the same amount of students. Altogether, there were 92 students. Write and solve an equation to find out how many were in each car. So usually, the let statements, if we're not sure what the variable represents, usually it's in the question. I'm doing kind of air quotes right now because it's not actually a question, it's a statement, but it says find out how many students were in each car. So I'm going to say let X represent the amount of students in each car. So guys, for each of these that we're going to do, there's going to be a let statement. And eventually, we'll see more than one let statement if we've got 2 variables. Not today, but going forward. So make sure that when you're doing your homework, right, we're not copying the question, but you're going to give me the let statement, you're going to give me the equation, and we can solve it, right? When we did this the first time, we hadn't solved equations yet, so we weren't solving them. Now we can solve them. So a bus brought 50 students, and then 6 cars brought the same amount. Okay, so if you want to think about it as a verbal model, it's the number of students in buses, or in the bus, plus the number of students in cars equals my total. Okay? And again, that's the way I wrote it's a little incomplete. I don't have a lot of space. It should be the number of students that rode in the bus plus the number of students that rode in the car is equal to the total number of students that went to the game. Well, we know that one bus had 50 students. So my equation here is I had 50 students on my bus, plus I had 6 cars that each had the same amount of students. And my variable X represents the amount of students in each of those cars, so 6X represents the total number of students that drove in cars, right? Because there were 6 cars, they each had X students, so if it was 10 students per car, it would be 6 times 10. If it's X students per car, it's going to be 6X equals 92. So that's my equation. Well, now this is pretty easy, guys. It's a 2-step equation. So I'm going to add negative 50 on both sides. I don't have space to rewrite, so I'm going to say divide 6. I'm going to get X equals 7. All right, and I'm going to write my answer, right? There were 7 students per car. Or I could say in each car or per car. So make sure that we write our answer in a sentence, right? If I'm saying X equals 7, well, what does that mean? Yeah, I know, it's great. We wrote the let statement, so we can go back and kind of put 2 and 2 together, but you want to answer it in a sentence, right? So we're going to write our let statement. Let X represent the amount of students in each car. I have my equation over there in green. That tells me that 7 is the number of students per car. I wrote my answer there in red. Now, I always get the question, or usually I pose the question, how would I check the equation? How would I check, let me dial that back. How would I check my answer? And someone always says, substitute into your equation. And I say, no. Now, why no? Well, we made that equation, right? The problem didn't come with the equation in green. I wrote it. I'm not perfect. I make mistakes. There's no guarantee that an equation I make to model a situation is right. How do we check it? Well, if you want to check, and again, I'm not requiring you to check, but I'm sure we want to make sure our answer is right, we go through the problem with our answer. So let's go through the problem. I've got 50 students on a bus. I've got 6 cars that I think had 7 students each. Well, 6 times 7 is 42 students. And 42 plus 50 is 92. That's my check. So if you want to check a word problem, again, for yourself to make sure that it's right, you work through the problem with your answer. We also know that if we get an answer that's negative or an answer that's a fraction, that we made a mistake, right? I know there weren't, 3/5 of a student per car. That would be a problem. There can't be negative 12 students per car. That would be a bigger problem, or just as big of a problem. So if you don't get an integer, we made a mistake, and we're going to go back and see how we can fix it. Let's look at this one. Randy has saved $780 for a guitar and some lessons. Here's a hint. We don't know how many lessons. That's probably going to be our variable. He bought a guitar for $500 and those lessons cost $35 each. Write and solve an equation to find how many lessons he can afford. Okay. Let X represent the amount of lessons. All right. Now, something we want to be careful with, and it's kind of subtle. You don't want to say let X represent, and I think I said this when we did this at the beginning of the year, but I'm sure some of us forgot. We don't want to say let X represent lessons, right? A variable is a letter that represents an unknown quantity, an unknown number. So it's got to be the amount of, the number of, the weight of, the height of, okay? It's not let X represent yards, let X represent miles, right? What about them? Especially when we're talking about items. Let X represent hats. What does that mean? Does that mean the amount of hats? Does it mean the cost per hat? Okay, so let's get back to this problem. He's got $780. He's going to spend it on two things. He's going to spend it on a guitar, as in one, and some lessons that are $35 each. Okay, so he's going to spend $500, plus he's spending $35 on each of his X lessons. So the total cost of his lessons is going to be 35X, right? If X is the number of lessons and they're $35 each, it's 35X, and that's equal to 780. Okay, there's my equation. Shouldn't be terribly difficult to solve. So I've got 35X equals 280. All right, so when I solve it, I get X equals 8. What does that mean? Let's answer the question. Randy can afford 8 lessons. Right? So the question isn't how many lessons did he get. We don't know what he's actually doing with his money other than the fact that he bought the guitar, but he can afford 8 lessons. And again, if you want to check it, you go back through the problem. 8 lessons at $35 each is $280, plus our $500 for the guitar gives us exactly $780. So once again, I wrote my let statement, I wrote my equation, I got my solution, and I wrote my answer in a sentence. Pretty similar one here, right? So she's, I'm not even going to solve this one. I'm going to do this one kind of quick because it's pretty similar to the last one. It says there's large pies for $12 plus $1.50 per topping. She's got this expensive pizza. How many toppings does it have? All right, well, you're kind of giving me the question. X represents the amount of toppings. All right, so what do I have? Well, the pie itself is $12, plus it's $1.50 per topping, and I have X toppings, and that's going to give me $22.50. All right, so that would be your equation, and when you solve it, I believe you're going to get X is equal to 7, but I think we need to move on because there's some other things that we need to cover. All right, car rental company charges a rental fee of $100 plus $4 per mile. You spend $252. All right, this one is pretty similar to the last one, right? How many miles did you drive? Well, there's my variable. Let X represent the number of or the amount of miles driven. And again, we're not going to say let X represent miles. What about the miles, right? That doesn't really mean anything. So how much money did we spend? Well, we spent $100 on the car, plus we spent $4 per mile, and we drove X miles. That's my equation. So if we add negative 100, we get 4X equals 152, which is going to give us, I believe, X is 38. And you'd write your sentence, the amount of miles driven was 38 miles. All right, this one's a little bit different. So it says Jimmy bought 7 guitar picks. He then tripled his collection, giving him 45. So this is one when it's a little different remotely, but when I do it in class, we generally make a lot of mistakes. So let's say you didn't see what I have written underneath, right, and solve an equation, right? And I say, well, what's my variable? And people are saying, well, it's how many he bought. And I say, no, it's not. He bought 7. That's a constant. And then we're going to say, he then tripled his collection. I'm not really sure. And then it says, write and solve an equation to find out how many he started with. Okay, so I'm going to say let P, I could use any variable I want, of course, but I want to do something different. Right, let P represent the number of picks Jimmy started with. Okay. So this one is going to be different for a few reasons, right? He bought 7 picks. Okay. Well, what happened first? Well, let's read our variable term. P is the number of picks he started with. All right. So now that's the beginning of my equation. Right? Right now, Jimmy's got P picks. Let's go back in time before anything happens. Right? It says he started with P picks. Okay. Jimmy bought 7 picks. Okay, great. Now he's got P plus 7. He's got whatever he started with plus 7. Okay. He then tripled his collection. How am I going to triple the quantity P plus 7? And then someone raises their hand and says, we need to use parentheses. And I say, thank you for sharing that with us. And that's, of course, correct. So how do I triple my new collection? My original collection is P. I got 7 more. Now my new collection is P plus 7. Now I triple that collection. So I have 3 groups of P plus 7, which gives me 45. Let's solve this equation to make sure it actually is right and that it makes sense. So I'm going to distribute, which is 3P plus 21 equals 45. And those of us that like to use a little shortcut, we could have divided by 21 at the beginning. I'm fine with that. So that's going to give me 3P equals 24. So that's going to give me P equals 8. All right, let's see if this works, right? Jimmy started with 8 picks. So again, I can't use my equation, right? That equation, I don't know how accurate that equation is. I don't know, I'm not tied to that. All right, so we think Jimmy started off with 8 picks. All right, he bought 7 more picks. So now I've got 15 picks. Now he tripled them. Okay, great. If I triple 15, it gives me 45. Oh, giving him 45. Wonderful. So my answer is correct. So again, you cannot check an equation. I could have came up with, yeah, hey, 3P, triple, and then plus 7. And I could do it this way. It's going to give me something a little bit strange, right? It's going to give me 12 and 2/3, and you can't have 2/3 of a guitar pick. But just so we're clear, guys, and obviously that's wrong, if you want to make sure your answer is correct, which I would encourage you to do, you're going to go back through the problem, and you're going to make sure it makes sense in the context of the problem. So here is your now try. So this is an easy one. James spent $150 on a pair, right? Kind of similar to the first 2 questions and the third question. And then he bought 7 shirts that each cost the same amount and only spent $241. So there's your now try. You can give it a pause. And then we'll come back and work through it. Determine the cost of each shirt. So I always get a few people that are like, X represents the number of shirts. Well, no. He bought 7 shirts. That's a constant. That's not a variable. We don't know what the shirt cost. So let X represent the cost per shirt. Okay. So let's think about James's purchase. He spent $150 on a pair of sneakers, right? That's one. Then he bought 7 shirts. How much did those shirts cost? The same amount. What is that amount? It's X. What did he spend in all? $241. This should be a pretty simple 2-step equation for us to solve, right? So I'm going to add negative 150 on both sides. So I should be looking at 7x equals 91. Divide both sides by 7, I should have x is equal to 13. But I'm not done, right? What does that mean? What does the 13 mean? Each shirt costs $13. Okay? Let's make sure we did this correctly. I don't know if this is correct. If I bought 7 shirts and they each cost $13, 7 times 13 is 91. So if I bought $91 worth of shirts plus $150 worth of sneakers, it's going to give me $241. So now I know with certainty that what we did was correct. My equation was good, we solved it correctly, and that our answer works in the context of the problem. Okay, guys, so your homework is all 3 of these. So what you're going to do is exactly what I just did. You don't need to copy the problem. You're going to write a let statement. So for number 1, let X or Y or P, whatever you want to use as your variable, represent the number of pencils. You're going to then write your equation. You're going to solve your equation, and you're going to write a sentence, right? Adrian bought 7,412 pencils, okay? Same thing for number 2. Number 2 is very similar to the Jimmy question with the guitar picks, except we're not going to need parentheses with number 2, right? Because he doubled them first and then bought 5. So 2 is not going to have parentheses. Number 3 will have parentheses, right? Yannick had some CDs, right? Kind of like the Jimmy question. He had X CDs or C CDs, then he bought 7 more. And then he doubled it. So at that point, X plus 7 is going to be doubled. We're going to put parentheses around it. We're going to put 2 outside the parentheses, and we're going to solve it. As always, guys, any questions when you upload your homework, put a comment on it, okay, on Google Classroom. That way I'll see it right away, and I should get back to you shortly.